cosine, adjacent, hypotenuse, and then tangent, opposite, adjacent, right? I've got an angle across that triangle on the opposite side is the opposite. That's the O. And then adjacent is the one next door to it that's not the hypotenuse. And the hypotenuse is always opposite the right angle. SOHCAHTOA. So the ADA requires a ratio of 1 to 12 for a ramp, right? That means 1 tall and 12 horizontal. So I could do 1 and 12 for my ramp, right? That's how I would do that. Ratio of 1 tall to 12 long. My question is that really 9 degrees? Okay, so if I put in SOHCAHTOA, right? I want to know this angle. That's my question mark. So the 1 is the O and the 12 is the A. Do I want to use sine, cosine, or tangent if I have the O and the A? Which one relates opposite and adjacent? Tangent. Okay, so we do tangent and we do a little -1. I kind of think of the -1 as that like little degree symbol. Okay, and then I just do O over A because tangent is opposite over adjacent, right? So 1 over 12. Then we're going to open up our Desmo. Right, so Desmo's graphing. Got to find your Desmo graphing calculator. Boom. And we could even split our screen. Maybe we should split our screen today. What were some of the things that I needed to remember when I did the Desmo's graphing calculator? I got to make it in what mode? Degrees. So I can put it in degree mode. I can pull my calculator out, right? I don't really need the graphing part. I'm trying to make that smaller. So I need to go to functions and find tangent. And I'm finding a degree, so I need that little -1, inverse tangent. And my fraction was 1 over 12, right? 1 over 12. That's 4.76 degrees. 4.76 degrees. So will 9 work? If I have a 9-degree angle instead of a 4.76 degree angle, this is going to be too tall, right? So instead of 9 degrees, it should be 4.76 degrees. This is just one example of why somebody might need to know this. I'm building a new, I don't know, extension onto my house. In order for my extension to pass code, my ramp can only have an angle of 4.76 degrees. If I accidentally make my angle 5 degrees, it's not going to pass inspection. Okay, so that's just one reason to kind of do this. These directions aren't really going to matter too much because we're not actually finding objects and measuring with a ground laser and all of the fun things that we were supposed to do today. So one of the things that I had to do yesterday was kind of change our paradigm. Here, is everybody with me? We've got an angle. So I've got a given angle is 63 degrees, right? That's this guy. And I've got the adjacent side, which is 40 degrees. And I've got a side, or 40 inches. So I still need to do SOHCAHTOA. I have my adjacent side and I want my opposite side. So what relates A and O? So sine, cosine, or tangent. What relates A and O? This is going to be that tangent, right? But this time I'm given an angle. So we're going to change our formula a little bit. We're going to do tangent of 63 equals, and then we're going to make our fraction the same. O is what I'm looking for, and A is what I know. Okay, so I'm going to put this fraction into my calculator. Notice when I have the degrees, I don't use that -1, and I put an equal sign. Okay, so the formula changed just a little bit. That's what happens when I have too many tabs. So if we come over here, we're going to do tangent of 63 equals x over 40. Where's my answer? Why doesn't it give me an answer this time?
Because you're getting it divided by 4.
Aha. So there is an answer over here. It's where my intercept is, 78.5. And let's see if what Riley's saying is true. So hold 78.5 in your head, and let's look over here. See if this comes back to life. So in order to solve this equation, I've got to multiply by 40 on the right side and multiply by 40 on the left side. So that's going to give me down here, x equals 40 times the tangent of 63. Okay. All I did was multiply by the denominator to solve my equation. So if I come back over here and I do 40 times tangent of 63, 78.5, which was, incidentally, where my line crossed. Okay. That means that over here, this height of this door is, oops, not 68, 78.3. And that was inches. Okay. So let's see if we can find another slide where this makes a little bit more sense. Okay. A little less stuff on the page. So we didn't use sine because we weren't looking for the hypotenuse. We were looking for the height. And this is where we multiplied. So we multiplied by the 40, right? This is where we would have done some work. So everybody meet me on slide 8. And this is where we should be able to start doing some real work. So I give you the angle at 74. So I want everybody to put 74 degrees in for your angle. Okay. I've got SOHCAHTOA, and we're going to do 2 of them. Okay. I know the opposite side, and I want to know the A, and I want to know the H. So if I know the opposite, this is given to me, I need to have the opposite in one of my formulas. So I'm not going to use cosine. Does that make sense to everybody? Yeah? So if I'm given the opposite, I have to use one of my things with opposite in it. I can't use cosine because it doesn't have the opposite. So then I'm just going to fill stuff in. So sine of my angle, which is 74, equals the opposite, 10, over h. Remember, I'm not using cosine, so I'm going to go straight to tangent. Tangent of my angle, which was given to me at 74, equals O, which is given to me 10 over A. These are the same questions from Friday. It's the same slides. I just changed them around a little bit. So it should be a different pair deck, though, Mikhail. Yeah, did the pair deck, were you able to get onto the pair deck? Let me put it in the chat again. It should give you these slides down, like we're on slide 8. Okay. So yeah, you should be able to write on it, and then I can see it in the pair deck. So here it's a little bit different because we have a variable on the bottom. So we've got to multiply by that variable, right? So h times sine of 74 equals 10. And then we've got to divide by sine of 74. Divide by sine 74. So the algebra gets a little bit weird. If the h is in the denominator, if you have a variable in the denominator, basically you just switch those two things. So I've got 10 divided by sine of 74. So I'm going to go back to my Desmos calculator, and I'm going to do 10 divided by, and then somebody said, how do I do sine, cosine, whatever? You can just type it in, sine, I just literally typed in the numbers, 74. Or you can do 10 divided by, and then go over to your functions over here, and there's a sine button. And then you can do 74. Desmos is pretty smart, so it's going to give you the same answer both ways. I can type in SIN, or I can go to the functions button and just click the button. But either way, we get 10.4. What does 10.4 mean? What was I finding? The hypotenuse. So this hypotenuse is 10.4 feet. And that makes sense because the hypotenuse should be longer than the opposite side, right? So if we remember that when I have a variable on the bottom, these two things just switch places. So A equals 10 divided by tangent 74. I go back to my Desmo calculator and I do 10 divided by, go to my button, find tangent, and 74. 2.867. So what do we want to round that to? 2.9 maybe? So H equals 10.4 feet and A equals 2.9 feet. And the whole reason to do this, to learn trig in the first place, is to be able to measure things that you can't measure with a ruler. Okay? That's kind of the idea. We're going to do a couple more together, and then I'm going to put you in breakout rooms and let you kind of work on them, and I'll pop in and out, okay? So let's mark everything we can mark. We've got a 61 degrees here, so this is my 61. This is the O. So if I do so, ka, toa, If I know the O, which function do I cross out? Which one do I not do? Because it doesn't have an O in it, right? So I want to find A and I want to find H. So how do I set this up? What do I put next to sine? Sine 61 equals O over H. So 8 over H. And what do I do when the H is on the bottom? Can I switch them? So that's going to find your H. And then tangent, same thing. Tangent of my angle, tangent 61, equals opposite, which is the 8, over the A. Because my variable is in the denominator, I'm going to flip these. So A equals 8 divided by tangent 61. So what'd you get for the H? And if I was predicting, I would say it's bigger than 8. So when you put that in the calculator, what do you get? 8 divided by sine of 61. And that's in feet. Nice. And then what about the A? That's probably going to be smaller than 8 because if this angle I'm given is 61, then this one is going to be 29. So the A is going to be my smallest side, so it's going to be less than 8. If you got it, you can put it in the chat too. 4.4, absolutely. A equals 4.4. And that's also in feet, right? So what trig does is if I give you an angle and a side, you can find the other two sides without having to measure them. Right? So if you own a tree cutting business and you charge, $500 for a 30-foot tree and $1,000 for a 60-foot tree, you need to be able to tell your clients that it's a 60-foot tree, right? So you can charge them that extra money. Let's look at 10. Yeah. Okay. So again, you're going to label the 47. I have the O. So I can use sine and I can use tangent, but I can't use cosine. And then you want to substitute in the 40 inches for your O's. So instead of O, I want to do 40. We can't solve this with the variable in the denominator. So you want to switch those and rewrite it. H equals 40 divided by sine 47. And A equals 40 divided by tangent 47. And you just want to put it in the calculator exactly the way you see it. So you want to do 40 divided by sine 47 and 40 divided by tangent 47. Make sure your calculator is in degree mode. That's super important. Remember, the hypotenuse should be your longest side. But 47 is really close to 45. So my green angle is 43. That's still going to be the smallest side, but it's going to be really close to 40. So did anybody get the small side or the hypotenuse? What'd you get? Mm-hmm. Nice. And those are both in inches. Okay, I'm going to flip through. So slide 11 is going to be where it changes a little bit. Okay, so let's do slide 11 together, and then I'll let you guys go work in groups. Absolutely. So here we know 31. So now we have the adjacent side. So katoa. So if I have the adjacent side, I can do cosine and I can do tangent, but I can't do sine because I have to find that opposite side. You're going to put them in the calculator the same way. Cosine of 31 equals adjacent over hypotenuse. And tangent of 31 equals opposite over adjacent. The trick here is how to put it in the calculator. So we've been practicing the hard way. If the variable's in the bottom, we've got to flip it around. So h equals 12 divided by cosine of 31. But if I have a number in the denominator, we can just multiply. Okay. I need to charge my calculator. So what do we get for the hypotenuse? Anybody got that? You got the height? Okay. What'd you get for the height? That is what I got as well. Perfect. That picture is not drawn to scale, is it? So do we want to keep working together or you want to go into breakout rooms? Together, together, together. Okay. So only in the pear deck. So or only in the slides. It doesn't matter to me where you show the work, whichever way is easier. The reason I put it in the pear deck is because I thought it's easier to draw on the pear deck than in the Google Slides. But if you like the slides, you can do it there too. Yeah. The good thing about pear deck is it auto saves, so you don't have to kind of worry about. Yeah, absolutely. Do it one or the other. You don't have to do both. Yeah. So we multiplied. So in the calculator, I put 12 times tangent of 31. Because basically you're solving a proportion here. So 1 times the opposite side, or 1x, equals 12 times the tangent of 31. So we're kind of solving a proportion there. It's a good question. I like hearing more voices. If you're confused, I guarantee 3 other people are confused. Trig is confusing until you get it. And it's brand new. It's like a foreign language. So let's look at slide 12. What's the first thing I label? So that Greek letter theta is 15, right? I'm given the A, so I write down SOHCAHTOA. A is the only thing I have, so I can't use sine, but I can use cosine and tangent. So now I'm going to substitute cosine of my angle equals adjacent over hypotenuse. So adjacent and hypotenuse become a fraction. Adjacent on the top and hypotenuse in the denominator. That's how I find cosine. Then I do the same thing with tangent. Tangent of my angle, because I'm given one. The O and the A become a fraction. So O over the 12. Sometimes I know I go too fast, so if I'm going too fast, let me know. On the left side, I've got that H in the denominator. So with an H in the denominator, I've got to switch. I can't have an H in the denominator. So H equals 12 divided by cosine of 15. So in my calculator, this is what I'm going to put in. I come over here to my calculator. So I put 12 divided by, and I tend to just type them, cosine 15. And we get 12.42. So the hypotenuse here is 12.42. And that's centimeters. That's the length of that hypotenuse. Over here, this one's easier. When I go to cross multiply, I just multiply those two things together. So the opposite side equals 12 times the tangent of 15. So in my calculator, I just put in 12 times tangent 15. 12 times tangent 15, and I get my number. And I think about, does that actually make sense? That's opposite the 15 degrees, so it should be really short. 3.2 centimeters. It's definitely a long, skinny rectangle. My smallest side is across from my smallest angle, and my medium side is across from my medium angle. And the largest side is the hypotenuse, always opposite the right angle. Is it starting to kind of solidify in your brain a little bit, or is it still swimming around a lot? Good. So in slide 13, things change again. What's changed here? Now we're given the H. So I still write my three things. So ka and toa. Which one do I have to cross out? Tangent. Can't use tangent because I have a hypotenuse and tangent doesn't work with hypotenuse. Okay. So you got to look at what you're given and then only use what you can. So we're going to work it out the same way. Sine 45 equals opposite over hypotenuse, opposite over hypotenuse. And cosine of 45 equals adjacent over hypotenuse. Do I switch them or multiply them? Multiply them. Yeah, so I have a number in the denominator, so I can just multiply, right? So O equals 16 times sine of 45, and A equals 16 times cosine of 45. And then we go to our calculator. What do we get? And I know that if this angle is 45, then this angle up here is also 45. So I predict I have an isosceles triangle here. Is 16 times the sine of 45 the same as 16 times the cosine of 45? I agree. Is it the same for both? Crazy how that works out. But this is an isosceles triangle, so I've got two angles that are exactly the same and two sides that are exactly the same. So same thing here. Mark your angle. Write in your SOHCAHTOA. Decide which functions you're going to use. Because I'm given the hypotenuse, I can't use tangent.
I have a question.
Mm-hmm.
How do you know what you can do like when you're doing sine, you have like how do you know if you put an angle or sine?
Gotcha. So sometimes what I do is I make like the A X and the O Y. Sometimes that helps a little bit. Sometimes it makes it confusing. But if the opposite side, if I make that a Y instead, then I've got a variable. So you always put in like sine of your angle equals O over H. So then you're just substituting what you have. So my angle is 83, so that's why it goes here. My H is 3, that's why it goes here. And my O is Y, that's why it goes here. I don't know if that answered your question, but cosine is the same thing. Cosine of whatever your angle is equals A over H. You always write it in that form. And then similarly, tangent of your angle equals O over A. Always the angle first. Mm-hmm. And because hypotenuse always goes on the bottom, if you're given the hypotenuse, you always multiply. And then it's just a matter of putting it in your calculator. Did anybody get an answer for the opposite side, the height of our triangle? So either unmute yourself or put it in the chat. What'd you get for the height and what'd you get for the ground distance, the A? Love it. 2.97. So it's almost 3. We can't call it 3 because this was 3. So it is almost, this is a flat, flat, flat triangle. What do we get for the ground? It's gonna be super short. Should be something different because you want to do cosine instead of sine. So it should be a tiny decimal. Yes. 0.36. I feel like once you get trig, it's like super gratifying in a very odd way because it seems so ridiculously crazy at the beginning. Sine opposite hypotenuse.
Yeah, the first letter stands for the first letter of the whole thing.
Absolutely. So sine opposite hypotenuse, cosine, adjacent, hypotenuse, and then tangent, opposite, adjacent. So, ka, toa. The adjacent side. The adjacent side was 0.36. Mm-hmm. So in this one, again, I have hypotenuse. So I can replace my hypotenuse with 12. And I've got my angle. My angle is 62. I can't do tangent because I don't have any of that information, right? So I'm going to do these two things. Remember, you're going to cross multiply. So sine 62 times 12. So in the calculator, 12 times sine 62. So in the chat, let me know what you got. And we can round to the nearest tenth. Hopefully everybody has their calculator out. Everybody's doing it. I want to make sure you're in degree mode. Mm-hmm. Is that the O or the A? Mm-hmm. Perfect. 10.595 or 10.6 for the O. And what about the A? Anybody got that? Can somebody confirm 5.6? Is that correct? And that makes sense because this was 62 degrees, which means this would be 28 degrees. So the adjacent should be the smallest side because it's opposite the smallest angle. And the 10.6 should be the medium side because it's opposite the medium angle. And the 12 feet is the largest side because the hypotenuse is always largest. Boom. Drop the mic. Let's look at 16. And that's our last one. I'm so excited. Awesome. So sine of our angle, opposite over hypotenuse. So sine opposite hypotenuse. And then cosine of my angle equals A over H. That's the ka. And then we've probably figured out by now that we don't need the tangent, but I'm going to write it anyway. That's our TOA. We're given the hypotenuse, so we can't use this one. Can replace my H with a 55. And replace my angle with a 25. Don't have anything in the denominator, so I'm just going to multiply. O is 23.2? Oh, yeah. Mm-hmm. Okay. And you could 100% round that to 50. So I am going to check these pair decks to make sure that you followed along with us and got all of the notes and everything. Today really was a note day. If it's still swimming around in your head a little bit, that is 100% normal. Tomorrow, hopefully, we can clean that up a little bit. Okay, but I do need you to try and just kind of make the connection, like Riley said, between S and sine and O and opposite and H and hypotenuse. You're always going to be given two pieces of information. So if you're given two sides, you can do Pythagorean theorem, a squared plus b squared equals c squared. If you're given two sides, you can do inverse tangent, where we just multiplied, and find the angles. And the hardest ones are these ones. If you're given a side and an angle, then you need to use real trig, solve the proportions. These are the hardest ones to find the missing sides. Okay? Yeah. Sure, because you were talking. I know that you were doing it. Yeah. Okay. Yeah. That's good. I just want to make sure we're kind of all on the same page for tomorrow. So that's why I stopped sharing. We can look back over here. I'm going to share one more time now that I have found where I wanted to be. So tomorrow we're going to do sides and angles kind of together. I might modify this a little bit tonight, so I wouldn't go look at it too much, but we're kind of going to go back to those sports questions, I think. And I added some more sports in, if it's the slides that I think it is. So tomorrow I really am going to put you in breakout rooms. So think about who you want to work with. We will do these first couple together. So these are just real traditional problems where I give you a side and an angle. We figure out what we're going to use. Then I give you two sides and we do the inverse trig like we did on Friday. So we're going to kind of review first. And then you're going to be doing these slides. So you're going to have to fill out the table and use Trig in order to do it. Okay. And there's definitely going to be some choices. And you're going to have to kind of problem solve in your group. But I added a basketball court, I added a swimming pool, and I added a rock climbing wall. Okay.
I noticed all of them are 90-degree angles.
They are. So in order for Trig to work, you have to have a 90-degree angle. And I didn't mark all of the 90-degree angles, but you can tell, like I'll tell you at the beginning of the day tomorrow, the one that looks like a right angle is definitely a right angle. And in fact, some of them we might need to, I did mark this one because it's not, because of the perspective of the drawing, it doesn't look 90 degrees, but it really is, because everybody knows the corner of a pool is 90-degree angle, right? And I think the gymnastics floor. So yeah, on the swimming pool, A is the 90-degree because that's a corner of the pool. So that'll be a good discussion point to have in your groups tomorrow. And then here, B is the 90-degree angle, and I did not mark that. So you'll have to know B is the 90-degree angle. Okay. So that's tomorrow. That's Wednesday. And then I think we've got one more day of practicing stuff. Yeah, patterns of right triangles. This is like a shortcut on Thursday. And then we're going to create our catapults on Friday. So if anybody wanted to do some research and find some YouTube videos about the best catapult to make, I'm really looking for some extravagant catapults. I don't want just like, all I'm giving you is to make the catapults is the popsicle sticks and stuff. But if anybody has some scrap wood laying around the house, if you can find one, I had one student build one year out of newspaper, like rolled up newspaper, and that made the body. So be creative. Think about how you can make a really cool catapult for us. Okay, I want some videos. But that is the end of class. I'm going to let you go about 10 minutes early, and I will see you mañana.
I was trying to figure out all this stuff out.
It does gel eventually, but it takes a little while, and it definitely takes some effort. I'm proud of you, Riley. Uh-huh. Gotcha. It's tough. Oh, that's so funny. You figured out the hard one first. That does not surprise me about you. I'm going to end class now. Lovely. Kevin, did you guys have any questions?
Wait, one more thing.
Yeah.
The first thing I ever said,
Oh, that was the video?
Yeah, that's the very first thing.
Oh my God. Pray. Wow, that's crazy. Thanks for sharing, Riley. Yikes. Yikes. All right, I'll see you tomorrow. Bye, sweetie. Hey, Mariah. How are you doing today? We will keep this schedule. Was that the question? Yeah. But then we'll get out early. Is I think what we'll do. Yeah, like we'll be done at 11:35 and then just like be done. Well, if we have any advisory stuff, we'll do advisory before we go for lunch. How's everybody feeling today? Feel like I was sucker punched a little bit. I know. You're okay with it, Thomas? Five in the morning? Playing that video game that's making you crazy? Oh no, playing? That's some aggressive